The broadcast is now starting. All attendees are in listen-only mode.
Hey guys, welcome to this session by Intellipaat. So today we've arranged for a session on Python interview questions, and just to let you guys know, this session would be simultaneously broadcasted to our customers on GoToWebinar, and it'll also be live on YouTube. So we'll start off by looking at some basic questions, and then we'll head on to the complicated ones. And these are some of the most frequently asked questions during a Python interview. Right. So let's start off with the first question. So this is a very simple question. And this is something which the interviewer would want you to definitely know. So what exactly is a list in Python? So simply put, a list is a collection of items. Now, this is an ordered collection of items, and these items are enclosed within square braces. So as you see over here, these are the items enclosed within the square braces. So we've got 1, A, true, and Sparta. Now, these elements could be of different nature or different data types. So what I basically mean to say over here is all of these items are heterogeneous in nature, and this is an ordered collection of data. Now, all of these items also have an index value associated with them, and the indexing starts from 0. So this is the item number 1, and the index for this would be 0. For this, it'll be 1, for this, it'll be 2, and for this, it'll be 3. Right. Now, what we'll do is we'll have a practical with respect to this list. So I'll start off by creating a list which would comprise of only numerical values. So I'll name this as num, and let me give in some values over here. So 1, 2, 3, 4, and 5, and I'll just print this out. Right, so this is a list which comprises of only numerical values. After this, I'll create a list which would comprise of, let's say, only alphabets. So I'll type in A, B, Right, so sorry for the delay, guys. So yeah, now let me just continue. So over here, as I was saying, here we are creating a list which would comprise of only characters. So I've given A, B. Now I'll go ahead and give in other characters. So I've got A, B, C, and D, and these are all of the elements which are present in this list. Now let me just print this out. Right, so this is my list which comprises of only alphabets. Now what I'll do is I will go ahead and create another list which would comprise of a mix of different elements or of elements of different data type. So let me type in all of those. So I've given 1, and then I'll give in a character. After that, let me give in a logical value. I'll give in 2, and then let me again give in a character over here. Now I'll give in a logical value again, and then I'll follow it up with a numerical value. Now let me just print this out. So as I've already told you, a list is an ordered collection of heterogeneous elements. And as we see over here, the individual entities, they do not lose their identity over here, right? So numerical value is represented as a numerical value. The logical value is represented as a logical value. And similarly, we've got this character over here, and this character is represented as a character value. Now let's see how can we extract individual elements from this entire list. So let's say if I wanted to extract only the first element or the first item from this entire list, then this is how we can do it. So I'll start off by giving the name of the list, and then I'll follow it up with a parenthesis, and I'll give in the index number. So since I want the first element, the index number for the first element would be 0. So I'll just put in 0 over here, and we've extracted the first element from this. Now similarly, if I wanted the last element from this, what I'll do is I'll give in -1. So when I put in -1 over here, then I'll get the last element, which is 3 over here. Now let's say I wanted a sequence of elements starting from 1 to true. So then 0, 1, 2, and it has to go on till 3. So mix, I'll put in the braces over here. So it starts at 0 and goes on till 3. Now what you have to note over here is, so the first term is inclusive and the last term is exclusive. That is, it'll start at 1 and then it'll go to 1 and 2. 3 would not be included. So we'll get the elements present at index number 0, index number 1, and index number 2. Now let me just click on run over here. right? So we've got the first three elements over here, 0, 1, and 2. So this is how we can work with the list. Now let's look at the next question. So what exactly is a dictionary in Python? So dictionary is another important data structure in Python, and this time this is a unordered collection of data. And this unordered collection of data is present in the form of key value pairs. So when I say key value pairs, let's just actually have a look at this example over here. So we've got three key value pairs over here. So here, 1 is the key and John is the value. 2 is the key, Bob is the value, and 3 is the key, Alice is the value. Right, now again, let's head back to Jupyter Notebook and work with dictionary. So I'll start off by creating my very first dictionary over here, and I'll name this as fruit. Now this would basically comprise of different fruit names and the quantity of those fruit names. So I'll type in apple, and let's say I've got 30 apples with me. After that, I'll type in banana, and I've got 50 bananas with me. And then I've got grapes. So I've got around 100 grapes with me. And finally, I've got mango, and I've got around 22 mangoes with me. Now, let me just print this out. Right, so this is our dictionary. So now another thing which you need to keep in mind is a dictionary, or all of the elements which are there in a dictionary, they are enclosed within curly braces. So when it comes to a list, the data elements are enclosed within square brackets, and when it comes to a dictionary, the elements are enclosed within curly braces. Right. Now let's see how can we extract the individual keys and individual values from this dictionary. Now what I want is, I want only the keys from this dictionary. So for that, I'd have to type in the name of the dictionary. I'll put in the dot operator, and I'll just type in keys. So I've extracted only the keys from this entire dictionary, which are apple, banana, grape, and mango. Now similarly, if I want only the values, I'll type in fruit dot values over here. Right, so now extracted only the values from this entire dictionary. So now we'll actually see how can we change the value of a particular key. So let's say if I have 50 apples instead of 30 apples. Now, if I want to change that value, so I'll type in the name of the dictionary first. I'll put in the parenthesis, and inside this, I'll give in the key name. So over here, the key is apple, and I'll change the value from 30 to 50. Now let me print this out again. Right, so now we see that initially the value of apple was 30. Now it has been changed to 50. Now let's see how can we add an extra element into our dictionary. So if you want to add an extra element, what I'd have to do is I'd have to give in a new key over here. So let's say I recently started to like strawberries. So I'll type in strawberry over here. And let's say I go ahead and purchase 500 strawberries. Let me just print this out. Right, so I've added a new key value pair over here. So the key is strawberry and the value for this is 500. Right. Now let's head on to the next question. So now what exactly is NumPy, and how can you create a basic one-dimensional and two-dimensional NumPy array? So NumPy is a scientific computing library, and it provides you multi-dimensional arrays on which you can perform different mathematical and scientific operations. So you basically have multi-dimensional arrays. Now let's go to Jupyter Notebook and work with these multi-dimensional arrays. So let me just add in a comment over here, NumPy. So to work with NumPy, we'd have to first import it. So to import it, I'd have to type in import NumPy as, and I'll give this an alias, np. Now this is the most commonly used alias for NumPy. Right. Now to create a NumPy array, we have np.array method. So I'll type in np.array, and this takes in a list as an argument. Now what I'll do is, let's say I'll give in 1, 2, and 3. So these are the three elements which are present in the list. Now I want to convert this list into a NumPy array. So I'll store this in A. Now let me just print this out. Right, so this is how we can create a one-dimensional array. So to create a one-dimensional array, we'd have to use the array method. So we'll type in np.array, and inside this we'd have to give in a list. Now we'll create a two-dimensional array. So to create a two-dimensional array, we'd have to give in a list of lists. So b equals np.array, and inside this I'll add in a list, and I'll add another list. So the first list would comprise of 1, 2, and 3, And the second list would comprise of the elements 4, 5, and 6. So this is basically a list of lists, and I'm converting this into a NumPy array. Let me just print this now. Right, so this is a two-dimensional NumPy array. Now this is a very interesting question. So how can you initialize a 5 cross 5 NumPy array which comprise of only zeros? Now this might seem very easy, and this is actually very easy. So there's one particular method in NumPy which is the zeros method, and with the help of this you can initialize all of your elements to zeros. So all I have to do is type in np.zeros, and inside this I'd have to give in the dimensions of my NumPy array. Since I want a 5 cross 5 matrix which comprise of all the zeros, I'll just put in 5, 5. I'll click on run. Right, so now I've got a NumPy array which comprise of only zeros, and this is a 5 cross 5 array. So we've got the fifth question over here. Now we've got two NumPy arrays. So first NumPy array comprise of 1, 2, and 3. Second NumPy array comprise of 4, 5, and 6. Now what I'd have to do is add the individual elements over this. So 4 plus 1 becomes 5, 5 plus 2 becomes 7, and 6 plus 3 becomes 9. Now let's go ahead and do this. So let me actually create these two NumPy arrays first. So A is equal to np.array 1, 2, and 3. Similarly, I'll create the second array, B equals np.array, and this would comprise of 4, 5, and 6. Now let me just print out A and B. So we've got our two NumPy arrays over here. Now I'd have to sum them up. So to sum two NumPy arrays, I've got the np.sum method, and this would basically take in these two as the parameters. So A, B. Now after this, I'd have to specify the axis parameter. Now I'll set the axis to be equal to 0. So now when I set the axis to be equal to 0, what this does is this basically adds the individual elements vertically. Now let's say if I wanted to add the elements horizontally. So for that, I'd have to set axis value to be equal to 1. And when I do this, what it does is it adds the elements horizontally. So 3 plus 2 plus 1 becomes 6, and 4 plus 5 plus 6 becomes 15. Now again, let me just put it to be 0 and go back to our original answer over here. Right, so 4 plus 1 is 5, 5 plus 2 is 7, and 6 plus 3 is 9. Right, so now we'd have to work something with pandas. So we'd have to create a data frame from a list and a dictionary. Right. So first let's start off by creating a data frame from a list. So I will name this list as L1, and I'll just give in values, some numerical values 1, 2, 3, 4, and 5. So first we'd have to start off by importing the pandas library. I'd have to type in import pandas as pd. Now to create a data frame, I'd have to say pd.dataframe, and inside this I'll just pass in the list, and I'll store it in a new object and name that object to be equal to df. Now let me just print this out. Right, so I have successfully created this data frame out of a list. Now let me go ahead and create a data frame out of a dictionary. So again, I'll name this as, let's say, my fruit. And over here, I have a key value pair. So the key would become the name of the column, and all of the values would become the row numbers. So I will give the key value, the key name as fruit, and the values would be the different names of fruits. So I've got apple, mango, I've got grapes, and I've also got guava. So this is my first key value pair. After this, I'll give in the quantity. So the second key would be quantity, and the values for this would be 10, 20, 30, and 40. Now, again, I'd have to use pd.dataframe, and inside this, I'll pass in this dictionary, which is my fruit. And I'll store this in a new object, and I'll name that object to be dffruit, and I'll print this out. So I'll just type in dffruit, and we've got our data frame over here. right? So I've successfully created two data frames. So the first data frame we created from a list, and the second data frame we created from a dictionary. Right. Now we have to do a bit of data manipulation. So we have this diamonds dataset with us, which comprise of all of these columns. And from all of these columns, if you have a glance at this price column, so we'd have to work with this. Now, we have to extract only those rows where the price is greater than 5,000. So let's perform this. So first, our first task would be to load this dataset. So to load a dataset, we'd have to type pd.read_csv. And I'll give in the name of the file. So the name of the file is diamonds.csv, and I'll store this in diamonds. Now let me have a glance at the head of this, diamonds.head. So we've got a dataset right over here. And the question basically stated that we have to extract all of those records where the price is greater than 5,000. So for this, we'd have to give in the condition. So the condition would be diamonds, and inside this, I'll give in the name of the column. So the name of the column is price, and this price has to be greater than 5,000. Now, let me just print this out and let's see what do we get. So we get a bunch of false values, and these false values basically denote that this condition has been evaluated to false, right? So wherever this condition is evaluated to true, that would mean the price of the diamond is greater than 5,000. So now what I'll do is I will put in diamonds over here, and I'll cut this out, and I'll paste the condition inside this, and I'll store this in a new data set. So I'll name this as d_price. Now let me just print this out, d_price.head. Right. So over here, as we look at the price, we see that we've extracted only those records where the price of the diamond is greater than 5,000. Right. So I seem to have a question over here. Yes, Shlok, so you seem to have a question.
So, could you also show an example where we can extract the records using multiple conditions, such as cut equal to ideal and color equal to E?
Okay, yep. So what Shlok basically over here is saying is, over here we've just used one condition. Now, instead of using one condition, we can give in multiple conditions and extract the records, right? So to extract multiple records, we'd have to use the AND operator. So as Shlok gave an example, we'd have to extract all those records where cut is equal to ideal and the color is equal to E. So what I'll do is I'll start off by giving the conditions. So diamonds, inside this, I'll give the name of the column, which is cut, and the cut has to be equal to ideal. So this is my first condition, and I'll paste this inside the parenthesis. I'll give in the AND operator, and inside this, I'll give in the second condition. So the second condition is diamonds, and this time this is the color. So the color needs to be equal to capital E. Now, whenever you're giving all of these conditions, you have to make sure that these spellings are correct, and you have to also take care of the small, whether it is in capitals or whether it is in small letters. So as you see, it is capital I, so I'd have to keep it as capital I, and over here it is capital E, so you'd have to put it as capital E over here. Now again, I will type in diamonds, and inside the parenthesis, I'll cut this all out and I'll paste this inside this. So I've given the condition, and I'll store this in a new data frame. So I'll name this as final. Now let me just have a glance at this new data frame over here, final.head. So as you see over here, we've extracted only those records where the cut of the diamond is equal to ideal and the color of the diamond is E. Right, so this is how you can give multiple conditions. So let me also give another condition over here. Now, along with these two conditions, let's say if I also wanted the depth to be greater than well, or less than 50. So let me do that. And let me give in the third condition over here. I'll copy this, I'll paste it over here. So this time, let me set the depth to be less than 50. And if we see, let's see if we have any result for this. So it seems like there is absolutely no record which would satisfy these three conditions. So instead of 50, let me put it to be 60 over here. Right, so this time we've extracted those records where the depth is less than 60, the color is equal to E, and the cut is equal to ideal. So this is how you can perform different data manipulation operations on a pandas data frame. Right, now we have this economics data set with us, and we'd have to introduce NA values, or basically missing values, in the first 5 rows of the date column and the population column. Right, so let me first again load up the data set. So I'll type in pd.read CSV again. And inside this, I'll give in the name of the data frame, which is economics.csv, and I'll store this in, let's say, econ. Let me print out the head of it, econ.head. Right, now I'd have to introduce NaN values in the first 5 rows of this column and this column. What I'll do is I'll actually create a duplicate of this data frame. So let me store this in econ1. Right, now whatever changes I'm making, I'll make them in this econ1 data set. So econ1 dot ilog, and I'd have to make those changes in the first 5 rows. So this will start from row number 0, go on till row number 5, and I'd have to make these changes in the first column. So the index of first column is 0. Now what I'll do is I will again give the main condition over here. So np.nan. So to the first 5 rows of this column, I'm introducing NaN values. Now let me have a glance at the head of this, econ1.head. Right, so I've successfully introduced NaN values in the first 5 rows of this data frame. All right. Now similarly, I'd have to also introduce NaN values in in this column over here. So this would be column number 2. Let me print this out, right? So I've introduced NaN values in these 2 columns. All right, so I have another question over here, and this is from Vinita.
So my question is, how can I get the number of NaN values in the data frame?
Okay, so you basically want the total number of NA values or missing values in this data frame. Okay. So for this, you'd have to type in econ1 dot, you basically have to type in np.sum dot sna. Let me just verify this. So this is econ1 dot sna, and after this you'd have to sum it up. So let me just print this out and let's see what do we get, right? So what we are basically doing is we're using 2 functions over here. So we've got the s.na function, which would basically check if that particular record comprises of NA value or not. Now after that, we will sum up all of the true values. So wherever it is true, we'll sum all of them up, and there it'll be added. So there's a counter which will keep on incrementing, right? So this basically shows us that there are 5 NA values in the date column and 5 NA values in the population column. So I hope this answered your question, Vinita. Right, now we have our next question over here. So now we'd have to create a simple line plot, and so this basically on the x-axis the values range from 0 to 10, and similarly on the y-axis the values range from 0 to 10, and we'd also have to assign labels for the x-axis, y-axis, and the title. Right. So I'll start off by creating the values for x-axis and y-axis. So for x, it'll be np.arange, and this would go from 1 to 10 since 11 is not inclusive. So it'll go from 1 to 10 and the increment would be +1. So this will be same for y as well. So I'll just change the name of the variable over here. So this is where we are getting our data from. Now, to create this line plot, I'd need the matplotlib library. So from matplotlib, I'll be importing the pyplot submodule. From matplotlib, import pyplot as plt, and this is the commonly used alias for pyplot. Now to create a line plot, I just have to type in plt.plot and given the x values and the y values over here. Let me just type in plt.show. Right, so this is how we can create a line plot. Now we also have to give the labels for this. So to add the labels, we've got plt.x label, and the x label is just x-axis. I'll type in x-axis over here, and then I'd have to type in the y label. This would be y-axis. Now I'd have to give the title. So this would be plt.title over here. This I'll just type in y versus x. So I've given all of this titles over here. Right. Now we've got another question over here. Right. So Devashish, what question do you have? Devashish, if you could go ahead with your question. Okay, so seems like Devashish is not available. I'll just head on to the next question then. Right. Now we'd have to go ahead and create a plot which would comprise of 4 graphs. So there are basically 4 line plots, and we'd have to plot all of them in the same graph over there. So let's do that. Now I'll actually copy this over here. So the x and the y values would be the same. This is where we're getting the x and the y values from. After this, we'd have to, we'd have to make a subplot. So with the help of subplot, we would have 4 plots in the same plotting area. So I'll type in plt.subplot, and this over here takes in 3 parameters. So the first parameter is number of rows, second parameter is number of columns, and next we'll given the plot which would have to make active. Right, so 2 rows, 2 columns, that would basically give us 4 plotting areas, and we are making this plot in the first slot over there. So plt.subplot and plt.plot over here. So I'll make the graph x, y. Now we'll go ahead and create the second subplot. To create the second subplot, so this will be the same plt.subplot 2, 2, and I'll make the second subplot to be active this time. Similarly, I'll create the third subplot over here. So 2, 2, 3, and then I'd finally add the fourth one over here. So 2, 2, and I'm making the fourth subplot to be active. Now to distinguish all of these line plots, what I'll do is I'll give a different color to all of these. So I'll go into plt.plot, I'll change the color. So for this, I'll give in green color. For this, I'll give in, let's say, red color. Color equals red. And for this, I'll give in yellow color. Color equals white. And finally, I just have to put in plt.show. Right? So we've created a plot which would comprise of 4 graphs, and all of those 4 graphs are present in one single plot. Right. So now we'd have to go ahead and create a bar plot which would show the names of fruits on the x-axis and quantity of the fruits on the y-axis. So let me first create a dictionary which would comprise of this data. So I'll just type in df over here. And first I'd have to give in the names of the fruits. So apple, let me just change the spelling over here. So I've got 30 apples with me. After that, I'll type in mango, and I've got 50 mangoes with me. And then I've got, let's say, strawberry. And I've got around 25 strawberries with me. Now what I'll do is, I'd have to separate out the keys and the values. So key equals, and since I want the keys, I'll type in df dot keys over here. And I actually want this in the form of a list. I'll convert this into a list. I'll store this over here. Now I also want the values. So list of, and inside this I'll store df dot values. So I've extracted the keys and the values from this. Let me just print out both of those separately. So key comma values. Right, so I've extracted the keys and the values from this entire dictionary. Now I'll go ahead and make this bar plot. I'll just type in plt.bar, and first I'd have to give in the key. After that, I'd have to give in the values over here. And then I'll just put in plt.show. Right, so we have successfully created our bar plot, which would comprise of the fruit names on the x-axis and the quantity of the fruits on the y-axis. Right, so Sami seems to have a question over here.
Hi, so I have a query that if I want these bars of this plot to display horizontally instead of vertically, so can I do that?
Yes, so you basically want these bars to be stacked horizontally. Okay. So it's actually very easy, Sami. All you have to do is change this method to bar hedge. That's pretty much it, right? So if you just have plt.bar, then you have these bars stacked vertically. Now instead of this, if you have these, if you put in bar hedge instead of bar, you'll get all of these bars stacked vertically, right? So this is how you'll do it. Right, so now we'd have to go ahead and create a pie plot which would show quantity of different fruits. Okay, again, another question on fruits. So what I'll do is I'll create two separate lists over here. In the first list, I would take in all of the fruit names. So I'll type apple again it'll be mango, and then I've got, let's say, orange. And after orange, I've got strawberry. So after fruit, I would need the quantity. So I've got 40 apples, 73 mangoes, 103 oranges, and only 4 strawberries. Now I'll go ahead and create this pie plot. So I'll type in plt.pie. So the first parameter would be the size, or basically the quantity, the numerical values of the distribution. So that would be present in quantity. After this, I'd have to give in the labels. So labels are present in the fruit list. Right. Now I'll just type in plt.show. Right. So this is our pie plot over here. So this is how we can create a pie plot. Right, so this basically shows us the distribution of different fruits. So I've got a question over here from Devashish.
Hi, can you please show us how can I get the percentage distribution over there? Is it possible?
Okay, so you basically want the percentage of each individual fruit, is it? The frequency of this fruit. Okay. So to add the percentage, or to basically show by how much distribution each fruit has or each of these value has, we have this parameter known as auto PCT, which basically stands for auto percentage. Now, what I'll do is this would take in a value something like this percentage. After that, I'll give in 0.1, and then I'll give in F, After that, I'll give in percentage. I'll click on run. Right, so now we've got these percentage values shown or displayed on this pie over here. Now this is basically, so this 0.1 basically stands for the number of decimals you want to see over here. So if it's 1, this will show you 1 decimal. Now if I change this to 2, you'll have 2 decimal values over here. Similarly, if I change this to 3, you'll have 3 decimal values over here. Right, so this is how it works. There's a question from Shlok Pandey. Yes, Shlok?
I want to increase the size of the plot. So how can I do it?
So you want to increase the size of this image? Okay. Yeah, so again, that's very simple. So we've got a method known as plt.figure. So let me just type it out, plt.figure, and over here you'll give in certain parameters over here. So you've got an argument known as fig size, which would basically stand for figure size, and inside this I'll give in the size to be 5,5. Right, so we've increased the size of this pie. Now let me actually increase this again. Let me put this to be 10,10. Now we've increased the size of the pie even more, right? So this is how you can change the size of the image. You have to keep in mind that you give this plt.figure command above this above the plot which you're making. Now let's say if I cut this and paste it below plt.py, then you'll get the image with the same size. So if you actually want this to work properly, then you'd have to give in above plt.py, right? Only then it'll work. Now we've got the next question. So we'd have to replace all the odd numbers in this numpy array to -1. Right, so let me go ahead and create a numpy array first. So a equals np.array, and I've got numbers starting from 0 going on till 10, and it is being incremented with 1. So I'd have to give in a list over here. So let me cut this out. Let me paste this inside the list. So this is actually np.arange, not np.array. Let me remove this out over here. So 0, 10, this has to be 11, 1. Right, so we have our array to be ready over here. Now what I want is I want to change all of the odd numbers to -1. So I'll give the condition over here. So if a%2 is not equal to 0, so if I divide the number by 2 and it is not equal to 0, then it would mean that this is an odd number. So if that is the case, then what I'll do inside this, I'll give in the value -1. So now let me print this out. Right, so wherever we had an odd number, I've changed that odd number to -1. So initially it was 1, I've changed it to -1. So here it is 3, I've changed it to -1. Right, now we have to get the common items between two numpy arrays. Okay, so let me create a numpy array first. A equals np.array, and I'll give in 1, 2, 3, 4, and I'll create another array over here. B equals np.array, and this time I'll give the values 4, 5, 6, and 7. So if you have a glance at both of these arrays, then you can make out that 4 is the common element. Now let's see how can we extract the common element from these two numpy arrays. So we've got this method np.intersect 1d, and inside this I'll just pass in both of the numpy arrays a comma b, and I'll get the element which is common to both of these, which is 4. So this is how we can get the elements at intersection for both the numpy arrays. Now we'll head on to the next question. So we've got this iris data frame over here. Now I'd have to change the name of the column of the sepal length to s length. All right, so let me load up the data set first. Iris, I'll type in pd.readcsv. Let me put in the braces over here. Let me give in the name of the file, which is iris.csv. Now I'll print out the head. So iris.head. Now I'd have to change the name of this column from sepal.length to s-length. So I'll start off by giving the name of the data frame, and I'll type in iris.rename. And this has a parameter called columns, and this would take a dictionary as an answer. So inside this, the key would be the column of which I'd have to change the name. So it is sepal.length. So this has to be capital L, and I want to change this to s_length. All right, now I'll store this in a new data frame, iris1, and I'll print out the head. So it'll be iris1.head. So initially the name of the column was sepal.length, and now I've renamed the column to s_length. So going ahead, we'd have to build a linear regression model. So this is our dataset over here. This is the Boston dataset. So this basically comprises of different factors which would influence the median price of a house. And over here, we'd have to build a linear regression model where our independent variable is RM and the dependent variable is MEDV. Or in other words, we'd want to understand how does the median value of the price of the house change with respect to this RM feature over here, right? So to build the linear regression model, we would require the sklearn package. So let me just import sklearn, import sklearn. Now let me load up the data set. So I'll store this in Boston. Again, pd.readcsv. And I will store this in boston.csv. I'll print out the head. So this is our Boston dataset over here, and it comprises of all of these columns. Now, as it was stated in the question, this was our dependent variable and this was our independent variable. So let me go ahead and extract these first. So in X, so X is basically the independent variable. I'd basically be storing the RM column, and in Y, I'd be storing the MEDV column. So Boston. And inside this, I'll give in the name of the column, which is MEDV. So I've extracted the independent variable and the dependent variable. Now I'll just print out the head of these two. So x.head, and I'll also print out y.head. Right, so I've got the independent and dependent variables over here. Now, after doing this, I'd have to divide my data into training and testing sets. So this is necessary because if we go ahead and fit our model only on our data set, then this would lead to overfitting. So our model will work properly on this data set, but whenever new data comes in, it'll fail miserably. So that is why we'd have to divide our data into training and testing set. And as it was stated in the question, our train size had to be 80 and the test size had to be 20. So let's go ahead and divide the data set. So I'll type in from sklearn.model selection. I'll be importing train test split. Now I'll use the train test split over here, and I'll pass in X and Y, which are my independent and dependent variables. And then I'll give in the test size over here. So the test size would be equal to 0.2. This would mean 20% of the records are in the test set and the rest 80% of the records are in the train set. So this would basically give me 4 outputs over here: X train, X test, Y train, and Y test. So over here, X train, it basically denotes all of your independent variables in the training set. X test denotes all of your independent variables in the test set. Then we've got Y train, which are basically all of your dependent variables in training set, and y test denotes all of your dependent variables in the test set. So now we've got this. Now we'd have to build the model on top of the training set. So the training set basically comprises of X train and Y train. And since we'd have to build the linear regression model, let me import this. So I'll type in from sklearn.linear model. I'd be importing linear regression. Now let me create an instance of this. So linear regression, and I'll store this in, let's say, lin reg. Right, so I've created an instance of the linear regression model. Now I'd have to fit the model on top of the train set. So lin reg dot fit, and I'll pass in X train and Y train inside this. So I've also built the model. Now we seem to have some sort of error. What exactly is it? If your data has a single feature, single sample. Okay, let me change this: X train, X test, Y train, and Y test. And this is what we have over here: train test split, lin reg, linear regression. So we've got X train and Y train over here. So, okay, so I'd have to actually extract this in the form of a data frame. So I'll cut this out over here and I'll paste this inside this. Similarly, I'll cut this out and I'll paste this inside this. So now what we have is, we'll have data frames of X and Y. I'll run this over here. I'll again run this. Right, so now we have successfully fit the model on top of the train set. So that error we've got because we'd have to pass in the independent variable and the dependent variable in the form of a pandas data frame. Now, if you don't do that, you'll get an error. You will basically get a shape mismatch error over there, right? So we've built the model. Now I'll finally go ahead and predict the values. So I'll type in lin reg dot predict, and I'd be predicting this on top of the test set. So I'll type in X test, and I will store the result in Y pred. So I've also predicted the values. Now I've got my actual values and the predicted values. Now to find out the error in accuracy, I have something known as the mean square error. So let me also calculate that. So from sklearn.metrics import mean square error. Let me type in mean squared error over here, and I'll pass in the actual values which are present in Y test. After that, I'll pass in the predicted values which are present in Y pred. Right, so this is the error in prediction. So 28.11 is the error in prediction for the model which we've built. All right. So Sami has a question over here.
So hi, so my question is that since you have only used one variable rm as independent variable, so if I want to use more than one variable for as independent variables, multiple independent variables, so that I can predict. So can you please show an example of that?
Okay, sure. So as Sami has asked over here, what we did over here was an example of simple linear regression. Now out there, when you're working on industry-based projects, you'd have to deal with multiple independent variables, right? So there might be different factors which you'd have to deal with. So to perform multiple multiple linear regression, you basically have multiple independent variables. Now the process is pretty much the same. All you have to do is your independent variables would comprise of a list of entities, right? So over here, we just had one independent variable. Now, instead of this, I'll have multiple independent variables. So over there, we just had RM. Now I'll also add, let's say, lstat into this, right? So I've got two independent variables now, but rest everything would be same. So now let's also compare the mean squared error. So initially, when we just had RM as our independent variable, the error in prediction was 28. Now we've included lstat. So let me go ahead and run all of these commands again. Right, so now when I've included lstat into this, the error has actually increased. So this means that when we are trying to understand the median price of the house, then RM is a better feature to compare MEDV with than lstat, right? So when we included LSTAT, the error of the model actually increased. So this would mean RM affects MEDV more than LSTAT. Right, so this is how you can work with multiple independent variables, and this is what is known as multiple linear regression. So that was regression. Now we'll also go ahead and see a classification model. So this time on the iris dataset, we'd have to build the decision tree classifier. And over here, species would be the dependent variable, and the rest of the columns would be the independent variables. So let me load up the iris dataset over here. Iris equals pd.read_csv. And inside this, I'll give in the name of the data frame, which is iris.csv. Now I'll have a glance at the head. So iris.head. Right, so this is our data frame over here. Now this is our dependent variable, and all of these are independent variables. So let me extract out the independent variable first. So x equals iris of, and I'll give in all of the names of these. So it'll be sepal length, and then we've got sepal width. This is capital W over here. After sepal width, we've got petal length. So let me just type in petal length over here. You'd have to make sure that you're taking care of the small letters and the capital letters over here, because it is extremely important. So if you mess it out, then you'll not get the right result. Right, so so all of these are my independent variables. I've got sepal length, sepal width, petal length, and petal width. And then going ahead, I'll extract the independent variable. So the dependent variable, which would be species. Now again, let me not make the same mistake and actually extract these out as a data frame over here. I'll cut this out and I'll paste this inside this. Let me also put in double braces over here. Let me cut this out and paste this inside this. Right. Now I'd have to go ahead and divide this into training and testing set. So let me copy the same command and paste it over here. So inside train test split, I'm passing x and y. X comprises of all of my independent variables, y comprises of my dependent variable, and this time the test size is 0.3. This means 30% of the records are present in the test set and 70% of the records are present in the train set. So we are done with splitting the model. Now we'd have to go ahead and build the model. So this time we are building decision tree. So from sklearn.tree, I'd have to import the decision tree classifier, and right now I'd have to create an instance of this. So decision tree classifier, and I'll name the instance as, let's say, DTC. Let me put it to be in small letters. Right, now I've also created an instance of this decision tree classifier. Now since I've created the instance, let me go ahead and fit the model on top of the train set. So DTC.fit, and I'm building this on top of X train and Y train. Right, so the model fitting is also done. Now we'd have to go ahead and predict the values. So DTC.predict, and I'll predict the values on top of the test set, which would be X test. And I will store the result in ypred. Now again, I've got the actual values and the predicted values. Now let me find out the accuracy. So from sklearn.metrics, I'd be importing accuracy score. And inside this, I'll give in the actual values which are present in y test. And then I'll give in the predicted values which are present in ypred. Right, so for this model which we've built, we've got an accuracy of 91%, which is actually very good. Right. And then we've got a final question over here. So this is an interesting question. So we'd have to create a user-defined function, dice, which would return a value between 1 to 6 every time we invoke it. Right, so we basically have to create a virtual dice over here. And to get a random number, we would need the random module. So I'll type in import random, and I'll create this function. So def, and the name of the function would be dice. So all I have to do is return. I'll type in. So let me put in braces over here. So I'd have to return random integer, and this random integer, the value would go from 1 to 6. So I have successfully created this over here, return dice. I'd have to put in parenthesis over here. Right, so I've successfully created my function. Now let me go ahead and invoke this. I'll type in dice. Right, so we've got 6. Now let me run this again. I get 5. Let me run this again. I get 1, right? So every time I invoke this, I get a value between 1 and 6. Right, guys, so this brings us to the end of this session on Python interview questions. So I hope that these set of questions were really helpful to you guys. And I also believe that if you perform all of these operations or all of these demos by yourself, then it will be very helpful for you to crack these Python interviews. Right, now just another information for you guys. So if you guys are interested in doing an end-to-end course in Python, then Intellipaat provides the Python certification course. So let me just show it to you guys. Intellipaat Python course. Let me just type it out. Right, so this is an end-to-end Python certification course by Intellipaat where you learn all the major concepts of Python. Right, so this is a 42 hours instructor-led training. So the best part of this training course is, it is always upgradable. So let's say we keep adding new modules and new topics to our course, and also we've got flexible class timing, so you can choose your own timing when you want to attend the session. Right, so let me actually go through the course content over here. Right, so you will learn all of these. So you'll start off by learning the basics of Python certification, and then you'll learn about the OOPS concepts. So you'll learn how to create classes. You'll learn about different concepts such as polymorphism, inheritance, and so on. And then you'll learn comprehensively about the NumPy package. So you'll learn all of the mathematical operations and scientific operations with NumPy. After that, you will learn about SciPy, which is basically built on top of NumPy. And then you'll learn how to do visualization with Matplotlib. After that, you'll learn how to do data manipulation with the Pandas library. And finally, you'll learn all of the machine learning concepts over here. So you'll learn how to implement random forest, linear regression, decision trees. So you'll learn how to implement all of these machine learning algorithms with scikit-learn package and with Python, right? And after this, you'll also learn how to do web scraping. So once you're done with this, if you want to be a good data scientist, you also need to have knowledge of big data. So this is where we also provide you how to connect Python with Hadoop and how to use Python for Apache Spark, right? So guys, if you are interested to enroll for this course, just check this course out. So this is a comprehensive course where you learn all of the end-to-end topics over here. And the best part of this course is you'll also get a 24/7 support over here. So if you have any doubts, we're always there to help you out. Right, guys? So this brings us to the end then. I hope you've had a good session. So